Welcome, dear students. In our today's class on chemical bonding, we are going to discuss some previous year's questions which came in board exams. So let us start our today's class solving questions. Question number 1. Draw the electron dot structure of ammonium ion and state the types of bonds present in it. What is the formula of ammonium ion? NH4 with positive sign, and the central atom is nitrogen. So we'll first draw nitrogen, okay? And the atomic number of nitrogen is 7, which means there are 5 valence electrons. So while drawing electron dot structure, we only need to draw the valence electrons. So the valence electrons of nitrogen is 5. So we'll draw 5 electrons this way, okay, boys? Now, each of these 3 electrons of nitrogen, they will take part in bond formation, okay, with the hydrogen atoms. So one hydrogen atom shares one electron with nitrogen and forms one covalent bond. In the same way, other 2 hydrogen atoms also share their individual electrons to form covalent bonds. So this is the 3 hydrogen atoms and 1 nitrogen atom bonded together in ammonia molecule, where there are 2 electrons which do not take part in bond formation. These 2 electrons, okay, and these 2 electrons, since they do not take part in bond formation, they are called lone pair of electrons. Is that clear? So if you are asked to draw the structure of ammonia, then you have to draw this structure showing lone pair also. Is that clear? But here we are asked to draw the structure of ammonium ion. Please note over here, many students, you made this mistake. Instead of drawing ammonium ion structure, you have ended up drawing ammonia structure. So please make sure there is a difference between ammonium ion and ammonia molecule. So this is ammonia molecule, but now we need to draw ammonium ion. So there is one more hydrogen in ammonium ion. So when a proton comes close to ammonia molecule, a proton means hydrogen ion which do not have any electrons left in it, okay? So this hydrogen, since it does not have any electron to share, therefore what this nitrogen does is it has 2 extra electrons. So this nitrogen will share both the electrons to form bond between nitrogen and this proton, okay? And this sharing leads to the formation of dative bond or coordinate bond. Is that clear, boys? So this is the final structure of ammonium ion, so where there are 3 hydrogen atoms bonded to nitrogen atom through 3 covalent bonds and 1 hydrogen atom bonded to nitrogen atom with a coordinate bond. But this is not over. Now this hydrogen, this proton had positive charge before, right? So what happens to this positive charge then? This positive charge will be shared among all the atoms in this molecule. And how do we show that? By drawing a square bracket and writing plus sign, positive sign outside the bracket at the top. Please do not forget to draw this plus sign, okay? Because this plus sign is now shared by whole ammonium ion. Is that clear, boys? That's why it is called ammonium ion. If you don't draw this plus sign, then it won't be ion, okay, which will be a blunder. So this is the final structure of ammonium ion. So now the second part of that question, state the types of bond present in it. So number 1, there are 3 covalent bonds, 1, 2 and 3 covalent bonds between 1 nitrogen atom and 3 hydrogen atoms, and there is 1 dative or coordinate bond between nitrogen atom and 1 hydrogen atom. Is that clear, students? Now let's move to another question. The one which is composed of all the 3 kinds of bonds, ionic, covalent and dative bond, is it sodium chloride, Is it carbon tetrachloride? Is it ammonia? Or is it ammonium chloride? So the question asks us to find out among these four options which compound has all the three types of bonds. So let's see one by one. Sodium chloride, number A option. Over here you can clearly see sodium chloride is made up of ions, sodium ion and chloride ion. Okay, so this contains ionic bond only. Let's go to option B, carbon tetrachloride. This is carbon tetrachloride. Carbon is a non-metal, chlorine is also non-metal. So non-metal, they share electrons to form bonds, so they have covalent bonds only. In the same way, let's go to ammonia over here. Ammonia, option C. Ammonia, nitrogen is non-metal, hydrogen is also non-metal, so they will form bond by sharing, mutual sharing. Okay, so over here there is also covalent bond only, and this 2 electrons of nitrogen remains as lone pair. Okay, so here also we have covalent bond. Now let's come to option D, ammonium chloride. So this is ammonium ion. Okay, and in ammonium ion we just learned that there are how many types of bonds? Covalent bonds and coordinate bond. This is in ammonium ion. Now it doesn't have until now it doesn't have ionic bond, but here we are given ammonium chloride. So this is just the structure of ammonium. So chloride means chlorine having negative charge. So when chloride ion comes close to ammonium ion, then these two oppositely charges, they attract each other by strong electrostatic force of attraction, and that leads to the formation of ionic bond. So we can see over here in ammonium chloride we have all the three types of bonds, and they are ionic bond, covalent bond and dative bond. So our answer to this question is answer number D, ammonium chloride. Is that clear? Now let's go to question number 3. An atom P has 287 electrons in its cell. It combines with Q having 2 electrons in its outermost cell. Number A, what type of bond will be formed between P and Q? And number B, write the formula of the compound formed. And number C, draw its electron dot structure. So according to question, P has valence electron 7. So this is the valence electron, okay? And which means that P is a non-metal. Whereas Q has valence electron 2, which means it is a metal. So let's go to question number A. What type of bond will be formed between P and Q? So P is non-metal and Q is metal. So what type of bond will they form? An ionic bond. So answer to question A is ionic bond or electrovalent bond, because P will gain electron and Q will lose electron, thereby formation of ions takes place. And whenever there are ions, oppositely charged ions, they will form ionic bond. Let's go to question number B. Write the formula of the compound formed between P and Q. So let's find out their valency first. P has valency 1. How do we find out? 8 minus valence electron 7 equals to 1. Whereas Q has valency 2. So now we all have learned how to write formula of a compound using valency by crisscross method. But while writing the formula, metal part is always written first and non-metal part is written second. So here metal part is Q. So this will be written first and P will be written second. You all make this type of mistake. You end up writing P first and Q later. So you always have to remember metal part is written first, that is electropositive part is written first, whereas non-metal electronegative part is written second. So here we'll write Q first. So Q has valency 2. So Q has valency 2 and P has valency 1. So this is all rough work. Okay, now crisscross method will do like this. So Q will get 1 and P will get 2. Therefore our answer will be QP2 is the formula of the compound formed by P and Q. Is that clear, students? Let's go to question number C. Now we know the formula of the compound QP2. That means Q, there is one atom and there are 2 P atoms. So let's draw electron dot structure. So Q, valence electron 2, will draw like this. Okay, now there are two P's. So one P over here and two P, another P over here. They all have 7 valence electron. Now this is an ionic compound, so there will be loss and gain of electrons. So Q will lose 1 electron and that will be accepted by P. Okay, in the same way, another valence electron of Q will be lost, and that lost electron will be gained by P. And this results in the formation of Q cation with 2 plus charge. Why? Because it is losing 2 electrons. Okay, and each P atom will gain 1 negative charge. Okay, so each P atom will now have 8 electrons. And why? Because they have gained 1 electron. So each P will have 1 negative charge. Now how many P atoms do we have? We have 2. So we'll write here 2. This, okay, so please don't write -2 over here. Okay, that will be again a blunder. So this 2 represents that there are 2 P atoms and each P atom has 1 negative charge. So this is the electron dot structure of the compound QP2. Is that clear, students? Let's take last question. The following table shows the electronic configuration of the elements A, B, C and D. So this is the electronic configuration. A 2,5, B 2,8,1, C 2,8,7 and D 1. The questions are: answer the following questions based on the table above. What type of bond is formed between B and C, A and D? Next set of question: what is the formula of the compound formed between C and D and B and C? Okay, so in such type of question, please do not attempt to find out what this A means. Okay, some of you end up writing this as nitrogen and write the answer as nitrogen, or D as hydrogen. Please do not make that mistake. Although D, by looking at its configuration, it is H, hydrogen, but you are asked to answer this question based on the given table where the elements are A, B, C and D. So you have to write A, B, C and D only. Is that clear, students? So let us start answering this question. Here we can see A, C and D are non-metals by looking at their electronic configuration. This is 5, so group 15. This is 7. So here 7 means group 17, and this D1, although it has 1 electron, so it will be metal as well as non-metal in group 1, but while forming bonds, compounds, this can be taken as non-metal. Okay, so A, C and D are non-metals, whereas B is a metal, group 1. Okay, alkali metals. So question number A1, what type of bond is formed between B and C? So B is metal and C is non-metal. So between B and C, metal and non-metal, what type of bond is formed? Ionic. So type of bond formed between B and C is ionic bond. Okay, next question, bond between A and D. So A is non-metal and D is also non-metal. So between non-metal, non-metal, what type of bond gets formed? Covalent bond. So A and D is covalent bond. Let's go to question number B. Formula of the compounds formed between number 1 C and D. So C is having valency 1, okay, and D also has valency 1. Now C and D has valency, both have valency 1, so it will be C1 D1. So it will be CD, correct? CD. But over here we have to see their electronegativities. Now D and C, between D and C, both are non-metals, but D has slightly less electronegative value compared to C. So we can say that D is slightly electropositive, whereas C is electronegative, and we always write electropositive in the front and electronegative later. Okay, so what will be the formula of the compound between C and D? It will be DC. Electropositive will be written in the first and electronegative will be written later. Number 2, between B and C. So B is a metal and C is a non-metal, both having valency 1. So the formula of the compound form will be BC. Is that clear, students? So this is how we have to answer questions based on chapter number 2, chemical bondings. You just have to use your understanding. Please stick to the questions given to you. Do not write your own notations. Please use the same notations which are given in the question. Until we meet next time, stay safe and do all things well.